Hi guys, in this video we're going to discuss something that's a little bit tricky, and I'm going to call it all those electrical things. Because there's all these different words when we talk about electrostatics that sound the same but are different. So we're gonna try and keep those straight. So our essential question is going to be about how do we keep those straight? How do we keep? Okay, so we're going to talk about electric force, electric field, electric potential energy, electric potential, and potential difference. And we're going to kind of talk about how to keep those straight. Okay, because it's a lot of words. They're kind of similar, but hopefully in this video you'll be able to keep them a little bit straighter. So I'm going to start by drawing some pictures, and then we'll compare all of these things together. So electric force means that we've got this charge here and this other charge here, and there is some force on this charge pulling it over. So, and that force is an electric force. For a negative charge, it would be pushing this way. For a positive charge, it would be pushing the other way. For electric field, what we're looking at instead is if I were to put any test charge around this, I would have, whoops, not inward, they'd be pointing outward. The outward ones, those are the right ones. The outward arrows, because it always goes in the direction of what if you put a positive charge there, and a positive charge is going to get pushed away. So then we would draw all these little arrows to indicate what that electric field looks like. They go out for a positive charge and in for a negative charge. Okay, so then there's electric potential energy. And electric potential energy is a lot like gravitational potential energy, but instead of a planet, we're talking about a charge. So some test charge out here has the potential to fall this distance, and so we find that potential energy. As soon as we let go, that potential energy is going to turn into kinetic energy, and it's going to start moving towards that other charge. Electric potential is like potential energy, except that we're talking about a test charge. So there's some amount of potential energy here and potential energy here and here and here and here. It doesn't exactly have direction, but it does have a value. And so we end up with a lot of times what they do is they do some color shading that there's more potential energy when you're closer. So maybe I'll draw some bigger dots here. And that might be able to show you the electric potential. But an electric potential is like a field, but we're talking about energy. How does the energy change per charge? The last thing is the potential difference. And I'm going to keep that here next to this picture here because we're talking about the difference between this point and this point. So the potential difference would be the difference between two particular points in that electric potential area. Okay, so let's talk about those in terms of the equations, and that might help you see it just a little bit better. So we've got electric force. Can you see that? Yeah, electric force. That is the F. That's K Q1 Q2 over distance squared. Okay, and the units that we use, I'm going to list over here. That is in Newton. Okay, for electric field, remember we're looking for the force per charge, per unit charge. So we're sticking in a positive test charge. This is E now. These are vector quantities. We're going to take the force per charge, literally. And one of those charges is going to drop out. So we'll have K Q over D squared, where this is whatever charge you're looking at. So you could find the value of the electric field at any point distance. So the unit there is newtons per coulomb. There's not a fun name for newtons per coulomb that I am aware of, at least right now. Okay, the next one would be electric potential energy. And electric potential energy is the work to move the charge. And you might recall that U is for potential energy, and to find work, we do a force times a distance. I didn't mean to write that up high. Force times a distance. And so if we do some fun combining of these, another way to write this one down is Q times the electric field times the distance. I know that's a kind of a nightmare, QED. So the potential field here, and a force times a distance is always a joule, which is a Newton meter. Okay, so there we are with the electric potential. Now the potential, the electric, that was electric potential energy. The electric potential, this is where it gets tricky. This is the potential energy per charge. And what we use this for is a V. V also stands for a variety of other things, so you have to try really hard to keep these straight. So electric potential V is the electric potential energy per charge, which is the same as taking that electric field times the distance. This one here has a fun unit. It's a joule per coulomb. You see we took the joule and divided by the coulombs, so we get a joule per coulomb. That is also called a volt, which is abbreviated to V. That's the annoying part. So we use V for electric potential, and we use V to measure it in our unit. That's one of the annoying things. The next annoying thing is this potential difference. The potential difference, this is kind of our lead-in to current electricity, because potential difference matters when we're talking about those charges moving around. We've been talking about them not moving. Potential difference is the change in electric potential. So it is literally, we use a triangle V for this one, and you take the final minus the initial, and so we're comparing those 2 points. Remember, in the picture, we're comparing those 2 points. It's just the difference to get from A to B. So the potential difference is the interesting thing. The potential difference here is what we're talking about. Now, the confusing part is that sometimes, and later on we're going to use for potential difference, we use V for potential difference also. So you have to kind of pay attention to what your question is asking. Is it asking for the electric potential, or is it asking for the potential difference? Sometimes they can be used in the same place. This one is also going to be measured in volts or joules per coulomb. Sometimes they'll talk to you about this distance as if it is the distance that you're changing. So one way you can do that is you can take the electric field times the change in distance. Again, it's really kind of annoying there. It just takes some practice to get used to the wording and to look for the wording and to know which thing you're trying to find. Drawing it on pictures, I find very helpful to think about what's going on when we're talking about the electric force or field or potential energy or potential difference. A picture's worth 1,000 words. All right, so if you have any questions, make sure you talk to your teacher. Thanks for watching.